Hello, my name is Kim, professor of Kalasarangan University, India. Today's topic is about analog to digital convert and digital to analog convert. Today, I want to give you some lecture about sampling theorem, and if we do not know the fmax, how to decide the fx. Okay. Then first, some terminology, sampling and quantization. Okay. The signal is represented in this graph, continuous time and continuous amplitude. We call this continuous time signal x of t. Otherwise, you can say analog signals. For example, like this. This signal, this is time domain C, and this continuous. This also amplitude also continuous. We call this continuous time signal, although you can say analog signal. Next, first we converting continuous time to discrete time here by, and we call process is sampling. For example, we call this discrete time signal x of n. For example, this kind. From this, you change it continuous time to discrete time. In this case, the sampling period equal 0.25 seconds. This sampling period equals TS. Okay, we call this a sampling time signal. And then we can convert continuous amplitude to discrete amplitude. Can convert. We call this quantization. Quantization in amplitude. We call this digital signal. Digital signal x of n. Of course, this digital signal can be used in computer. For example, like this. This is also discrete. This is also discrete. Okay. Okay. Then what is the condition of the AD conversion? AD conversion. That means here original signal x of t. This is continuous time signal, and through the AD convert, we can get x of n discrete time signal. And this discrete time signal comes to the DA convert, and at the final you can get x of t, this continuous time signal also. The continuous time signal, should be equal. Theoretically. Through even though the signal past this converts, but it should be same theoretically, not practical. Theoretically, should be same. But in practical case, it's not equals. Almost the same x of st. Okay. Also, this converts at AD convert can contains sampling function, quantization function, and the encoding functions. Today, mainly I would like to explain to you the sampling concept. Sampling means continuous time to discrete time. This. Okay. Then for this sampling means, as you know, the sampling means continuous time x of t to x of n. For this, we need sampling frequencies. Okay. Then how frequently do we have to sample the continuous signal? How frequently? Okay. This is a basic concept, key point. Okay. For example, this kind of this kind of signals here. This is original signal is blue, and the red is a discrete time signal. Now we are sampled by this is sampled by 0.5 seconds. In this case, 0.25 seconds. In this case, 0.125 5 seconds. We call this sampling period. Okay, now of course you can guess we have many signals of this time signal cycle. It's easily to recover the blue signal. That's all mean that x of n convert to x over t. If we have more signals, it's easily to recover the x over t original signal. That means the more samples, the better to recover the x over t with x over n. Then we need many samples. But I think let's see the amount of information. This is much more like this. For example, if we can recover the original with this a little bit smaller number of samples, of course, you can see x over t is the best of them. Otherwise, the smaller number, we take a smaller number, this one, from this, if we can recover the x over t, this is the best one. Therefore, this, how to decide the sampling periods. For example, 0.5 is okay, 0.25 is okay, 0.25 is okay, or more, the short interval is okay. I'm not sure. Anyway, how to decide sampling period? Okay, this is main questions. This is important thing. Okay. Okay. I'll give you one quiz. Who is this man? 100 years before, one man was born in Michigan in U.S. He achieved many theorems in communication field as well as electrical and mathematics. Especially, he set the bridge which connect analog to digital. Who is this man? Okay, he's very famous for some Shannon. Okay, Shannon. He is the founder of some information theory. Okay, Shannon is very important person in DSP field. Okay, by his theory, we call this a sampling theory. Sampling theory means how to convert continuous time signal to discrete time signal x over n. For this, we need sampling frequency. How to decide the sampling frequency? Okay. Of course, before Shannon, 1928, Nyquist, he introduced already, and 1949 by Shannon, the theorem is widely spread. Okay. Then, what is the sampling theorem? That means sampling frequency for converting discrete continuous to discrete. This is sampling frequency is greater than 2 times of fmax. Fmax means maximum frequency in signals, especially equal to 2 times of xm equal to Nyquist frequency. Okay, that is very important concept in sampling theorem. Okay, this one more time. Sampling frequency is greater than 2 times of upper max. Okay. Sometimes they are using equal, but this is not included. Please pay attention. Just greater than, not equal. Okay. Okay. One example. Now x of t is here is given. From this, what is the fs? Okay. Then from this cosine 100 pi t. This means, this means 2 pi ft. Therefore, this is f equal 50 hertz. Okay, and from this we can know f equal 100 hertz, and from this what we can know is f equal 200 hertz. Therefore, the maximum frequency of this signal is, this is f max, f max. Therefore, fs is greater than 2 times f max means 400. Okay. Then we can choose the sampling frequency to be more than 400 Hz. We can convert x over t to x over n, and also from this we can recover the x over t if we use this kind of sampling frequencies. Okay. Then if we do not know f max, how to decide? Just before, if we know this, fs is greater than 2 times of f max, but now this we do not know, then this is we cannot do. Then what shall we do? Okay. In generally, all signals, the frequency range of all signals is 0 to infinite, theoretically 0 to infinite frequencies. Then, of course, f max equal infinite frequency. Then also sampling frequency also should be infinite. Then this means, is it possible? No, that is impossible. Okay. Then what we have to do is we have to make f max to be finite, not infinite, finite. Okay. Then how to make f max finite? Okay. Theoretically, f max equal infinite. How to make this? For this, okay. First, we can assume f max. Then how to assume? It depends on your choice. That means what is the maximum frequency you desire? If you desire 100, then you can take 100. If the frequency you desire is 1 kilohertz, then you can get f max go to 1 kilohertz. Like this. Then is it okay? Just you assume? No. We need to make f max to finite. How to do that? That means here. For example, frequency. Okay, now frequency is here, 0 to infinite. Okay. Then how to make this? It's very simple. Now you apply just this kind of low pass filter. You apply this filter to the signal, and then this is f cutoff frequency. Beyond the cutoff frequency, gain is all 0. This is 0. Gain equals 0. This is 1. Then you can get output is like this. This is f max, because this is all 0. Then you can know the f max. From this, you can decide fs. Okay, very simple. One time, for this, you have to use low pass filter. And this concept is very, very important. Because most of cases, we do not know f max. We do not know this. We do not know then how to do that. We have to do like this. Assume, and we need to apply low pass filter to signals with the cutoff frequency to be equal to f max. Okay. Now you have one question. This kind of low pass filter is analog or digital? Yes, this is analog, because low pass filter is placed before AD conversion. Therefore, this is analog, not digital filters. Therefore, we need from this x over continuous time signal x over t to x over n, we need AD converter. For using this, because we do not know f max, we do not know, therefore we use the low pass filter like this. Okay, this is very important concept. Okay, this is one of the quiz is there. Please solve this problem. Very simple one. Now this is the Matlab source program for your reference. From this, what you can do is you can make this kind of the input signal, continuous time signal, by using the two kind of frequency. If you enter, then you can make any arbitrary signals. And also, we can make this kind of discrete time signal also n by the fs you entered. Then you can make this one. Please practice how to make x over n, x of t, and x over n. Thank you so much for your watching. Today I explained to you a first class of AD conversion, sampling theorem. Sampling frequency is greater than 2 times over f max. Okay, then we do not know f max. We need to low pass filter. The concept of low pass filter is that. Okay, before about this, let me explain later in my lecture. Actually, also for this kind of analysis of sampling factor in frequency domain also is very important. But now this analysis of this theory will be later in my lecture after explaining my lecture about the frequency concept. Now that I didn't explain the frequency domain, therefore after frequency domain, and I will explain this kind of sampling process one more time. The next topic is quantization in the process of x over t to x over n. Please look forward to next lecture. Thank you so much again.